This is Unit 9, Kinetics and Equilibrium. Lesson 2, Energy Changes in Chemical Reactions. How is energy calculated during chemical reactions? The objectives of this lesson, I can determine if a reaction is endothermic or exothermic, and I can use Table I to identify the type of reaction. Do now. So delta H is defined as the heat of the reaction. So this is a little bit of a review from our heat unit, thermochemistry. The amount of heat energy lost or gained throughout a reaction. So the way we calculate the heat of the reaction is the H of the products, the heat of the products minus the heat of the reactants. It's always products minus reactants. Delta H stands for enthalpy, and that H is where that enthalpy comes from. Enthalpy is another word for heat. The different types of chemical reactions that we are going to be discussing right now include endothermic reactions, where heat is absorbed by the reactants and energy is stored in chemical bonds of products. The delta H for endothermic is always positive. And whenever we write it as a chemical reaction, the energy is going to be on the left side as a reactant. For example, if I take the reaction A plus B and I produce C, the way I calculate that delta H is I take the delta H of A, which is 40 kilojoules, and the delta H of B, which is 20 kilojoules. Then the reactants have a total of 60 kilojoules. So if delta H of C is equal to 110 kilojoules, then 110 minus 60, the products minus the reactants, is going to equal a positive 50 kilojoules of heat. This must have been absorbed by the reactants. So then I would write that energy as a reactant on the left-hand side. Total energy on both sides are equal, and this is our law of conservation of energy. So make note of this. I would star this as one of your key terms or key concepts. An example from Table I to review. Recall at the very bottom of Table I, a minus sign indicates an exothermic reaction. Ooh, look what I just did. I'm going to fix that because that's ugly. A minus sign indicates an exothermic reaction. Oh, I did it again. Therefore, if I have a positive sign for any of those reactions, that reaction as endothermic and energy was absorbed. Our second type are exothermic reactions. Heat is released as a product or exiting, and the delta H is negative. For our purposes, this is a more stable reaction, and this is what we will say occurs spontaneously. And when I write it as a formula, my energy is a product. So an example using some numbers, if I take that same reaction, A plus B is going to produce C. If the H of A is 60 kilojoules and the H of B is 40, then the reactants have a total of 100 kilojoules. If the H of C, the heat of C is 30 kilojoules, then I'm going to take my products minus my reactants, and that's going to equal a negative 70 kilojoules, and that's how much heat must have been released as a product. So we write this as our formula. A plus B is going to produce C plus our heat that is exiting are 70 kilojoules. The total energy on both sides of the equation are equal. This is our law of conservation of energy. So an example from Table I, our minus sign here, this reaction as written has a negative 393.5 kilojoules of heat released, and this is an exothermic reaction. Recall if I reverse the reactions on Table I, I'm going to reverse the sign of that delta H. So what is the delta H of the following reaction? Is this exothermic or endothermic? So the way it's written this way, if you find this reaction on Table I, you'll see it's just the opposite. This reaction written as so is a negative 571.6 kilojoules. If I reverse it, turn it all the way around, I have to reverse that sign. Therefore, the reverse reaction is endothermic. If I change the moles of the compounds, recall the coefficient in front of each compound represents the number of moles of that compound. If we want to change, for example, double or half, the number of moles of a substance, we must change everything in the equation by that factor, including the heat. So for example, at 101.3 kilopascals and 298 Kelvin, don't let this confuse you. If you look at the top of Table I, you'll see those values there. What is the total amount of heat released when 1 mole of aluminum oxide is formed from its elements? So if you pull out your reference table, I have mine right here, look on table I. I know you don't have it out, so get it out. You're going to find on table I aluminum oxide, Al2O3. It's about a third of the way down. It's formed from its elements, aluminum and oxygen. This is asking 1 mole. If you notice in that equation on table I, you produce 2 moles. To produce 2 moles of Al2O3, it's going to be a negative 3,351 kilojoules released. So if you went to go for this answer, that's not correct because it wants 1 mole. So 1 mole of this is going to be half that value, which would be 1676. So check your understanding. And now you can determine if a reaction is endothermic or exothermic, and you can use table I to identify the type of reaction.